In this first example, I'm given the side opposite the 30-degree angle, which is the shortest side, which in the reference triangle, the shortest side is x. The longer leg is going to be x times the square root of 3. So here, instead of x, I'm going to have 10, actually. So we have 10 times the square root of 3. My hypotenuse is going to be double the short leg, so it's going to be 2x, 2 times 10. Next example, I have the longer leg, but there's no square root of 3 visible, so looking at the reference triangle, 6 is equal to the leg times the square root of 3. So we have to solve for the shortest leg, so I'm going to divide both sides by the square root of 3. Can't leave that radical in the denominator, so I'm going to multiply both numerator and denominator by the square root of 3 over 3. Square root of 3 over the square root of 3, so I get 6 times the square root of 3 over 3, which reduces to 2 times the square root of 3. So that means that my short leg is 2 times the square root of 3. For the hypotenuse, we're just going to double that, and we're going to get 4 times the square root of 3. And that's the basics of the 30, 60, 90. For the tangent, sine, and cosine portion, we're going to write up here, the old aunt sat on her coat and hat. So we see what our ratios are for the tangent, opposite over adjacent, sine, opposite over hypotenuse, and cosine, adjacent over hypotenuse. So the first example, we're using our 32-degree angle here. The 5 is the opposite, x is the adjacent, so that tells us we're going to have to use the tangent of 32 degrees is equal to the opposite, which is 5, over the adjacent, which is x. When we cross multiply, we have x is equal to the tangent of 32, or x times the tangent of 32 is equal to 5 times 1, which is 5. So then we're going to have to divide both sides by the tangent of 32. So we have 5 is equal, or x is equal to 5 divided by the tangent of 32. So now we're going to plug that into our calculator. 5 divided by tan 32. I'm going to close my parentheses just for good habit. And we get 8. So x is equal to 8. Next example, we have to be given a little bit more information here. So I'll say that those two lines are parallel. So in that case, we know that alternate interior angles are equal, so that's 50. And because, let's see, in order to get x, I'm going to need more information. So I'm going to have to find the length of this line right here in order to help me find x. So let's call this y. So then what function am I going to need? Well, if I use this 50-degree angle, the 6 would be the opposite side, y would be the hypotenuse. So which one of my functions deals with opposite and hypotenuse? It's that sine. So we're going to take the sine of 50 degrees is equal to the opposite side 6 over the hypotenuse, which is y. Put that over 1 when we cross multiply, we have y times the sine of 50 is equal to 6 times 1, or 6. To solve for y, we're going to have to divide both sides by the sine of 50. So y is equal to 6 divided by the sine of 50. So into our calculator, 6 divided by sine 50. I'm going to end my parenthesis there. And we get 7.8. So this piece is 7.8. So I'm not finished yet, because now I have to use this information to help me solve for that x. So what function, if I'm using this 50-degree angle, the 7.8 is the adjacent side, x is the hypotenuse. So adjacent and hypotenuse is our cosine function, so we're going to say cosine of 50 degrees is equal to the adjacent 7.8 divided by the hypotenuse x. Cross multiplying, we get x times the cosine of 50 is equal to 7.8. Divide both sides by cosine of 50, so we get x is equal to 7.8 divided by the cosine of 50. Plug that into our calculators. 7.8 divided by cosine 50, and we get 12. X is equal to 12.1. On the test tomorrow, we're just going to make sure that we read the directions and see if we want it to the nearest tenths or the nearest hundredths place. Next example, we're looking for the angle. So we're going to set up using our functions the same way. We first think, what function do we need? 10 is the opposite from the angle, 22 is the hypotenuse. So what function deals with the opposite and the hypotenuse? Opposite hypotenuse is the sine again, so I'm going to take the sine of x is equal to 10 divided by 22. We can use our table of trig values or we can use our calculator. First I can find 10 divided by 22 as a decimal point, and I have the sine of x equals 0.4545. I look down my sine column on my chart and I see where does the cosine equal, or where does the sine equal? 0.4545, and it's approximately 27 degrees. Or I can use the inverse on my calculator, and I can say second function sine 10 divided by 22 and parenthesis equal, and we get 27. So x is equal to 27 degrees. Next, for x, 12 would be the opposite, 8 would be the adjacent. So we go back to our functions and we see what function deals with opposite and adjacent. So the tangent of x is equal to 12 divided by 8. Go to your calculator. We're looking for the angle, so we're going to use second function tangent. 12 divided by 8, and that's equal to 56. So x is equal to 56.3 degrees. Okay, story problem. The base of an isosceles triangle is 70 centimeters long. So we draw an isosceles triangle. The base is 70 centimeters. It says the altitude drawn to the base is 75, so we'll put that 75 centimeters there. Base, when the altitude is drawn to the base of an isosceles triangle, it cuts it in half, so each one of these is going to be 35. We want to find the measure of the angle. So what function, 75 would be the opposite, 35 would be the adjacent, because we're just going to concentrate on this triangle right here, that right triangle. So I'll say the tangent of x is equal to 75 divided by 35. So once again, we're looking for the angle. So we're going to take the second function tangent, 75 divided by 35, and we have 64.98, so I'm going to give that a 65 degrees. So x equals 65, it says to the nearest degree, so we're good. Next one, an observer located 3 kilometers from a rocket launch site sees a rocket at an angle of elevation of 38 degrees. How far is the rocket at that moment? Okay, so we got a rocket. We have an observer. Here's our little person over here. Angle of elevation to the rocket, it says, is 38 degrees. Our person, our observer, is located 3 kilometers from where the rocket launches, and we want to know how high is the rocket at that moment. So we want to know the altitude of that rocket. So we have, with this 38 degrees, we have x is the opposite, 3 is the adjacent. So once again, we have the tangent function. So I'm going to have the tangent of 38 degrees is equal to x over 3. So this is the nice one when x is in the numerator, because when we cross multiply, we just have 3 times tangent of 38, and that is equal to, what a good number, 2.34. And you're done.